So before we learn about the chi-square test, it is good to learn t-distribution test. So t-distribution, that in other words we can also call a t-test. T-test is refers a statistical test which is mainly used to determine whether there is a significant differences between the means of variables or not. It is applied when the sample size is small, usually n is less than 30. The population standard deviation is unknown. The data is approximately normally distributed. This test is mainly based on the student t-distribution test developed by the William Seeley Gossett. The main application of these tests is to compare the mean of a sample with the population mean. It is also being used to compare the mean of one sample with the mean of another independent sample. It also being used to compare the values, that is readings of one sample but in two occasions. Let's talk about the sample mean and the population means. Then how it will apply the t-test when the sample mean and the population mean is given in the particular question. The journal step of testing hypothesis must be followed, whether it could be a null hypothesis or an alternate hypothesis. So null hypothesis, which is a sample mean which is equal to the population mean, and the degree of freedom to calculate, that is n minus n 1, that is n is a number of observation. So t is equal to the x bar minus the population mean by the standard error. So the major formula of the t-test, that is t is equal to x bar, that is a sample mean minus population mean by standard error, that means s by under root n. S is a sample standard deviation and n is a sample size, and when we calculate the standard error, which is equal to the s by root n. Let's take an example to understand the t-test. So the following data represent the hemoglobin values in GM/DL for 10 patients, that is 10.5, 9, 6.5, 8, 11, 7, 7.5 till 12. The question is the mean value for patients significantly differ from the mean value of the journal population, that is 12 GM/DL. Evaluate the role of chance. The major solution is mentioned that all the steps to calculate the degree of freedom, then formulate the hypothesis, then use the statistic formula and the values which is already been given, that put the values into the formula. So that called a sample mean, that is 8.95 minus population mean, that is 12, by sample standard deviation, that is 1.80201 by under root 10, the exact value of t, which is equal to the minus 0.132. That means the calculated t value is minus 5.132. Then the next step is to compare the t value with the tabulated value for 9. That means there are 10 observations of values, that is n is 10 minus 1, which is equal to 9. Hence it is being tested by a 5% level of significance, and when we look up the table value, you can see at 5% of degree of freedom is 9, we can easily see the tabulated value, the t tabulated value, which is equal to 2.262, and hence the calculated value is more than the tabulated value. That means we reject the null hypothesis, and once we reject the null hypothesis, then we could say that there is a statistical significant difference between the mean of sample and the population mean, and this difference is unlikely due to a chance. But how to see the t tabulated value? That's called, this is a table in the next slide. This is a table of t distribution critical values of t, and hence we can look up the 5% significance value, and the degree of freedom is given, that is 9. If you look up the 5% degree of freedom, that is two tail test, that is 5%, so we can look up the 9 degree freedom, that is 2.262. so this is a degree of, this is a tabulated, a t tabulated value, that is 2.262. So as the t calculated value is 5.832, that means the t calculated value is more than the t table value, that is 2.962. 2.262. That means we reject the null hypothesis. The rules of the t distribution test is that there are two main rules, that if the calculated value is less than the tabulated value, that means the t table value, that means the null hypothesis is accepted. That means there is no statistical difference between the mean of the variable. The next rule is that if the t calculated value is more than the t table value or tabulated value, then the null hypothesis is rejected. That means there is a statistical significant difference between the mean of the variables, and in this particular question it has been shown that the t calculated value is 5 point, you can say 352, and the table value is 2.262. that means that the calculated value, what is t calculated value? There is a formula which has been shown in the earlier slides. We use the formula, values has been calculated and given in the question, and once we put the values into the question, we calculated the t calculated value, which is 5.352. And once we, after that, we need to calculate the degree of freedom, that is n minus 1. But in the question there are 10 values, so n is 10. So 10 minus 1, it becomes 9. So 9 is a degree of freedom. In the question it is mentioned that to test at 5% level of significance. So this 5% of level on which we need to estimate the t tabulated value. And in the next table, in the next slide, the table has been shown, that is under 5% level of significance and degree of freedom is 9. We have estimated the tabulated value, that is 2.2, you can say 62. So this is the value of t tabulated. We just compare the values, which is where the t calculated value is more than the t tabulated value. That means the null hypothesis is rejected. So there is a statistical difference between the means of a sample. That means it is likely due to a chance, and that's the exact conclusion of this question. Now we can come up to the next section, that is the types of t-tests. That is one sample t-test. It compares the sample mean with the known population mean. For example, checking if the average weight of student differs from 70 kg or not. So when we compare with the sample mean with the known population mean, it's called one sample t test. The second type is independent, that's called a two sample t-test, where the two independent groups values like rise and weight, the individual values has been given and we have to compare the means of these two independent groups. Then we use the independent or two sample t-test. For example, comparing the average marks of class A versus class B. So if we comparing the mean of these two classes, we use the independent t-test, and it is mentioned in the question that which test you have to follow in estimating the values and make a comparison of two independent groups. So this is a case of two independent samples. The following data represent the weight in kg for 10 males and 12 females. So as the 10 males is given, that is 80, 75 till 65, and females are given, that is 60, begin with 60 until 82. So in the question it is mentioned that is there is any statistical significant difference between the mean weight of males and females, and the alpha, that means a level of significance, is 1%. To solve, it follows the step and use this equation. So when we are using a two independent samples of mean, we use this formula, that is x minus x bar, that's called by under root, that is S1, that is N1 minus, you can say standard error, by you can say N2 minus ds by N1 plus N2 into 1 by N1 plus 1 by N2, and this is how the formula to be used in case of the two independent samples. And these are the results, that is in the following up question, 10 males and 12 females. So mean males, the mean of males is 72.7, and mean of females, that is 67.17. Variance of males, that is 128.46. Variance of female, that is 157, that is 787. And of course there are two independent groups, so the formula to calculate the two independent groups, that is N1 plus N2 minus 2, is equal to 20. So if you look up 11 plus 11, or you can say plus 12, it becomes minus 2 is equal to 20. Then how to calculate the calculate t value? Then putting up the values into the formula, we have estimated the t calculated value, that is 1.074. So we compare the tabulated value at 0.01, that's the value is called 2.845. So hence the calculated value is 1.074 and the tabulated value is 2.845. So once we compare the calculated value and the table value, that means we accept the null hypothesis and conclude that there is no significant difference between the two means, and this difference may due to the chance, and that's why the p is greater than the 0.01, that means it is a significance level. The P is stands for probability value. If any value, probability value is more than 0.01, it means that we accept the null hypothesis. If the probability value is less than 0.01, that means we reject the null hypothesis. The next test is a paired t-test where it compares the two related measurements. For example, comparing the student marks before and after the training. So that's called the paired t-test. When to use t-test? Use a t-test when the sample size is small, population standard deviation is unknown, data is approximately normal, and it comparing the means. So this is how the statistical methods for difference or paired sample. When a particular researcher or individuals compare the differences or the paired samples. So we have a question, are the data continuous? If yes, then the next question arises, are the data any differences shown or that differences are normally distributed or not? If yes, then we could refer the or use the paired t-test. If no, then we can use the Wilcoxon's matched paired test. So this is how we have to estimate that which test is referred when the any data is continuous, whether it is normally distributed or not. If it is normally distributed, it is paired t-test. If it is not, that's Wilcoxon matched paired test could be used. So let's talk about the paired t-test. Let's take an example. A celostic blood pressure SBP of 9 normal individuals who had been recumbent for 5 minutes was taken. Then 2 ml of 0.5 solution of hypotensive drug was given and the blood pressure recorded again. Did the injection of drug lower than the blood pressure? So this is a question and we have to answer this question by resolving the values of the, you can say, t and the tabulated value, and if you look up the significance level, that is 0.05%. So this is how the values are given in the question. So the values is already given in the question, serial number 1 to 9, the blood pressure before injection and the blood pressure after injection is already given in the question. So our first task is hypothesis. If we talk about HO, there is no mean difference. If we talk about HE, that is alternate hypothesis, it's a mean difference. If HO, that is no mean differences. Then we need to calculate the differences. How to calculate the differences? X1 and X2 is already given, because how it could called a paired t-test. If the values of X1 is 9 and this and the another variable, the values are 9, when both are equal, 9 equals 9 of variable 1 and variable 2, then we could use the paired t-test. So the second step is to calculate the differences, that is X1 and X2. So once we calculate the values, that is 122 minus 122, 121 minus 118, you can say 3, 120 minus 115, 5, 115 minus 1105 and so on. That is called the differences between the variables x1 and x2. Then we have the next step is square. We have to square, we need a summation or sigma x square. So we just square the differences of the values 2, that is 4, 3, that is 9, 5, that is 25, again 5, that is 25, 4, 16, 0 as 0, 4, 16 and 1, 1, 3 and 9. So the ultimate total is 105. So the x square is 105. Difference total is 27 and n is 9. As we need to calculate the standard deviation of the mean difference. Before we need to calculate the mean difference. So the x bar is equal to sigma x bar by n. What is the difference here? That is 27 by 9. N is a number of observation, that is 9. So we have an answer of mean difference, that is 3. Now the another task is to calculate the standard deviation of mean difference. How to calculate the standard deviation in case of individual series? That is sigma x square by sigma x whole square by n minus 1. So this is a formula of standard deviation in case of individual series. So we have a values that sigma x square is 105, sigma x that is 27 and n is 9. So 105 minus 27 into 27 by 9 minus 1, that ultimately the overall values which has been estimated, that is under root by 24 by 8, which is equal to root 3, that is 1.73. So that means the mean difference is 3 and the standard deviation of mean difference is 1.73. Then the next step, calculate the standard error of mean difference. So once we calculate the standard error, what is the formula? As we have I already told you that standard deviation by under root n. So what is the standard deviation? That is 1.73 by n is 9 under root 9, which is equal to 0.58. So this is how we have to calculate when we use the paired t-test. We need three things. First is mean difference, second is standard deviation of mean difference, and the third one is standard error difference. So I already shown the formulas to use, and accordingly we need to calculate the values and put the values into the formula. We get all the three x parameters values. Then the next step is to calculate the test statistic, that means t calculated value. And what is the formula to calculate the t value under the paired t test, which is equal to x bar by SE, that is standard error. So x bar, that is the mean of mean difference, that is 3 by standard error, that is 0.58. So once we divide the 3 by 0.58, we get the t statistic value, that is 5.17, and the degree of freedom, which is equal to n minus 1, that is equal to 9 minus 1, which is equal to 8. Then our next task is to check on or to estimate or to look the t tabulated value. So this is a table t critical values where the next task is, we have already calculated the degree of freedom, that is 8. 8 is a degree of freedom because n minus 1, that means that is 8. Then 5 level of significance is already given in the question, and the t statist value, that t tabulated value we have seen, the value is already given. Degree of freedom is 8, and the 0.05 is the level of significance. So we have estimated the t tabulated value, that is 2.31. So t tabulated value is 2.31. So the next is whether we have to accept the hypothesis or reject the hypothesis. So this is how we can show through the diagrammatic representation. So as you can see that as we took a central value, that is 0, that is when we talk about the right hand side, that is 1 to 3, and left hand side is a negative value. So if you look up the negative values, or if it comes minus 2.31, we reject the null hypothesis. And same if the values comes above the 2.5, we also reject the null hypothesis. As the values comes between 0 to 2.5, that means we rather than accept the null hypothesis, we reject the null hypothesis. So this value is automatically shows that the null hypothesis is rejected. So that means, in other words, we could say that the calculated value is more than the tabulated value, that is 2.31, hence the null hypothesis is rejected, and this value is also arrives in the rejection region, and hence the null hypothesis is rejected. And when the null hypothesis is rejected, that means there is a significant difference between the means at 5% level of significance. And this is how we could represent the conclusion with the help of diagrammatic representations. The next section is what are the factors which affect the sample size decision. The first factor is a population size. The total number of people and items in the group anyone is studying. Larger population require the larger samples. After a certain point, it becomes small. The next one is the level of accuracy, that is called the margin of error. How close you want the sample result to be the true population value. The smaller the margin of error, the larger the sample size required. Confidence level, the probability that the sample truly represents the population. The commonly level are 90%, 95%, 99%. So higher the confidence level, that means the larger the sample size required. The next factor is a population variability, that's called standard deviation. If the population has a higher variability, it needs a larger sample to represent the samples accurately. If the population is homogeneous, a small sample may be sufficient. The next is a type of sampling method. Methods like simple random sampling, stratified sampling, cluster sampling can also influence the required sample size. The next factor which affect the sample size decision, that's called research design. Experimental studies like descriptive studies, exploratory study may require a different sample sizes. The next is available resources. Time, cost, manpower is also limit the sample size that can predictably could be used. The next a factor could be expected response rate. Sometimes the respondents may not respond to the questions. Researcher then increase the sample size to compensate the missing information of the respondents. The next factor could be the purpose of the study. Studies requiring a high precision, for example, medical research, need larger samples compared to the exploratory or pilot studies. The next is chi-square test. What is exactly the chi-square test is? Before that, it is important to know the important terms. The first is a parametric test, the test in where the population constants like mean, standard deviation, standard error, correlation, proportion, and the data tends to follow one assumed or established distribution such as normal, binomial, and Poisson. That is called the parametric test. So every population factors constant. If any individual follow any one established distribution, that could become a parametric test. Non-parametric test, it refers a test when there is no constant of the population is used. Data, there is no need of any data to follow any specific distribution like normal, binomial, Poisson, and no assumptions are required to these tests, and that calls a non-parametric test. For example, to classify good, better, and best, we just allocate the attributary numbers or mark to each category. The next concept is hypothesis. It is a definite statement about the population parameters. Null hypothesis, that states that there is no association between the two variables in the population, and those variables are statistically independent. If we want to compare two methods, method A and B, for its superiority, and if the assumption is that both methods are equally good, then this assumption is called null hypothesis. The next is alternate hypothesis. It refers that the two variables are interrelated to each other in the population. If we assume that from two methods, method A is superior than method B, then the assumption is called alternative hypothesis. The next concept is a degree of freedom. It denotes the extent of independence, that is freedom, enjoyed by a set of observed frequencies. For example, we are given a set of n observed frequency which are subjected to k independent constraint or restrictions. Then df is calculated as the number of independent constraint on them, or in other words, df is equal to r stands for number of rows minus 1 into number of columns minus 1. The next concept is a consistency table. When a table is prepared by the enumeration of data, especially when it comes to the qualitative data, by entering the actual frequency, then if that table represents the occurrence of two set of events, that's called the consistency table, like con together. In French, in Latin, we can call a con together, tangerine to touch. It is also called an association table as well. So let's talk about the chi-square test. Chi-square test is an important test which reflects the several tests of significance developed by statisticians. It was developed by Carl Pearson in 1900. Chi-square test is a non-parametric test, or which is not based on any assumption or distribution of any variable. This statistical test follows a specific distribution known as chi-square distribution. And in general, the test will use to measure the difference between what is observed and what is expected according to the assumed hypothesis are exactly called the chi-square test. Important characteristic of this test is known as a non-parametric test which based on observed and expected frequencies, which is not on any observation like mean, mode or standard deviation or standard error as well. The test is used for testing the hypothesis and is not useful for estimation. This test can be applied for a complex consistency table with several classes like A, B, C, D, E as very useful in research work. This test is an important non-parametric test because as there is no fixed assumptions involved in such test. And in fact, there is no need of any parameters values and it's less mathematical details are involved. This is a chi-square distribution where we talk about the bell-shaped, L-shaped and reverse shaped, and we can see here the degree of freedom with respect of these shapes, that is 159 degree of freedom. So degree of freedoms, it could be estimated when the sample size is large. And how it denotes such shapes we can see here. If the degree of freedom is more than 2, that means distribution is bell shaped. If degree of freedom is equal to 2, it becomes L-shaped with maximum ordinate at 0. If degree of freedom is less than 2, that the distribution would be L-shaped with infinite ordinate at the origin level. Applications of a chi-square test. This test can be used in goodness of fit of distribution. Second is a test of independence of attributes, and the last one is a test of homogeneity. So let's have an overview of these tests. The test of goodness of fit of distribution. So this test enables that how well the assumed theoretical distribution such as binomial, Poisson and nominal fit to the observed data, and that's why the chi-square test is equal to calculate the goodness of fit, that is sigma O minus E by E. O minus E whole square by E, that is the formula of chi-square test. O is the observed frequency and E is the expected frequency. And if the rules are, if the chi-square calculated value is more than the chi-square tabulated value with n minus 1, then the null hypothesis is rejected, otherwise accepted. If the null hypothesis is accepted, it can be concluded that the given distribution follows a theoretical distributions. The next application is a test of independence of attributes. Test enables us that whether to explain whether or not two attributes are associated to each other. For example, if may be interested in knowing whether a new medicine is effective in controlling fever or not, chi-square test is useful. In such a situation, we can proceed with the null hypothesis that the two attributes fever and medicine are independent, which means new medicine is not effective in controlling fever. So if the response could say and the values of calculate chi-square calculated value is more than the chi-square tabulated value at a level of significance with a degree of freedom, the null hypothesis rejected. That means two variables are dependent to each other. otherwise it's accepted. The next is test of homogeneity. This test can also be used whether the occurrence of events follow any uniformity or not. That means, for example, the admission of patients in government hospital in all days of week is uniform or not can be tested with the help of chi-square test, and the same rules are to be followed. So if the chi-square calculated value is less than the chi-square tabulated value, then the null hypothesis is accepted. So it can be concluded that there is a uniformity in the occurrence of the events. So this is a calculation of the chi-square test. The chi-square is equal to the sigma O minus E whole square by E. O is the observed frequency and E is the expected frequency. If the two distributions, either observed and theoretical, are exactly alike, that is chi-square is equal to 0, but generally due to the sampling errors, chi-square is not equal to 0. Steps involved in calculating the chi-square test. First, task of a researcher or learner to calculate the expected frequencies and the observed frequencies. Expected frequency, the cell's frequency that could be expected in the contingency table if two variables were statistically independent. Observed frequency, the cell frequencies actually observed in the actual table. It means if any frequencies given in the question or in the table that called an observed frequency, and with the help of the observed frequencies or using up the formula, we can easily calculate the expected frequency, and this is a formula which has been mentioned on the slide. Expected frequency, that is FE, is equal to total column, the value of total column into the value of total row by grand total. So to obtain the expected frequency for any cell, it is important to apply this formula to calculate the expected frequencies. Conditions for the application of chi-square test: the data must be in the form of frequencies, and the frequency data must be in a precise numerical value and must be organized into categories or groups. Observations recorded and used are collected on a random basis. All the items in the sample must be independent. No group should contain a very few items, maybe less than 10. So whether a frequency, if when the frequencies are less than 10, so regrouping of the frequency could be possible until and unless adjoining the groups so that the new frequencies become greater than 10. The overall number of items must also be reasonably large, and it should be normally at least 50. So let's talk about the applications of the chi-square formula. So it is mainly used for biology and medicine, studying the genetics, disease prevalence, and the treatment effectiveness. Social science, it also aims to analyze the survey data, opinion polls, and social behavior. Market research, it also aims to assess the consumers' preferences, product choices, and brand loyalty. In case of education, it aims to evaluate the effectiveness of teaching methods and learning outcomes. Finance, it aims to analyze the investment patterns and assessment of risks. Genetics, it aims to testing for genetic leakage and association in population studies. And the next is epidemiology, that is aims to investigate the disease outbreaks and the risk factors in public health. So in every area, the chi-square test and the formula is used. So let's take in a question. A dice is thrown 132 times with frequency results. And number a turn up, that is 1 2 3 4 till 6, and the frequency is 16 20 25 14 29 28. So the question is the dice unbased? So the hypothesis could be generated that the dice is unbased, and the probability of obtaining any of the you can say 6 numbers, that is 1 by 6, and in such expected frequency could be any number, any one number coming upwards, that means 132 times. So 132 times into 1 by 6, it could be 22, and 22 would be the expected frequencies. So in the question is already given number turn up, that is 1 to 6, an observed frequency, that is 16 to 28, and the expected frequency, that is 1 by 6, because the 6 numbers 1 by probability of 6, that is 1 by 6, and 132 times occurs, so 132 by 1 by 6, which is equal to 22. O minus E, that means the first step to calculate and reaches the value of chi-square, that is O minus E. So O is the observed frequency and E is the expected frequency. So O minus E, that is 16 minus 22 minus 6, 20 minus 22 minus 2, 25 minus 22 is 3, then 14 minus 20 minus 8, and so on. Then the next step is to square the difference of observed and expected frequency. So 6 into 6, 36, 2 into 2, 4, and so on. So we need to calculate the chi-square value, that is O minus, what is the formula is O minus E whole square by E. So O minus E whole square, it's already been calculated individually. We just to divide O minus E whole square by E, and E is already calculated 22. So O minus E by E, that means 36 divided by 22, the value is occur 0.36 or 39, then 4 divided by 22, then you can say 9 divided by 22, and so on. So the values is also been by dividing the values is already calculated and estimated. Then we have already estimated the value is 9. So the chi-square value is 9, and the degree of freedom, that is n. N, how many values are 6? So 6 minus 1 is 5. So once we look up the value of chi-square for 5 freedom and 5%, the value, the chi-square tabulated value is 11.071. So comparing the calculated and table and the level of significance and the chi-square table value is also been given in the question. So in the question is given that is 11.071. So we just compare the chi-square calculated value with the chi-square table value, and we get the results. So the table value chi-square for 5 degree of freedom at 5% level of significance is 11.071. So compared the calculated and the table values of chi-square, we find that the calculated value is less than the table value, and as such could have arisen due to the fluctuation of samples. That means we support the hypothesis or we accept the null hypothesis, and it could be concluded that the dice is unbased. So this is how We estimated the chi-square value and we have concluded the results as well. The next concept is a aid correction. So in the 2 into 2 contingency tables, the expected frequencies are small, say less than 5, then the chi-square test cannot be used. In the conditions of the chi-square test, if the values, expected frequencies values is more than 10 or is reaches to 50, then the chi-square test is applied or used. But if the expected frequencies are small, say less than 5, then the chi-square test cannot be used. In that case, the direct formula of the chi-square test is modified and given by Yates correction for continuity. So the formula is given, that is sigma modulus E O minus E minus 0.5 whole square by E. So O is the observed frequency, E is the expected frequency, and 0.5 is a Yates corrector factor. In short, subtract 0.5 from the absolute difference between the observed and expected frequency before squaring them. So this is exactly called a overview of the Yates correction. Let's take another example of the chi-square test. For example, a total of 1500 workers on two operators A and B were classified as deaf and non-deaf according to the following table, and we need to find out, is there any association between the deafness and the type of operator, and the level of significance is 0.05. So this is a table, that is operator A and B, deaf, frequencies 10 and 60, because the value is already given in the question. So that could be the observed frequencies. So in case of operator A, deaf is 100, non-deaf is 900, and the total of operator A is 1000. In case of operator B, deaf is 60 and non-deaf is 440. That means total it becomes 500. So the total is deaf is 160 and the non-deaf is 1340 and 1500. And 1500 is a total of row and total of column. And once the total of row and total of column is same, that could become a grand total. So grand total is 1500. Now it's already given that the total number of items is 1500, that is grand total. In other words, total number of defective items, that is 160, which is given in the question. Now we have to estimate the expected frequency, total of row into total of column by grand total. GT is grand total, which I already told 1500 is a grand total. If we look up the total of row, like for example, if we need to calculate the that D, that is D first row and first column, to calculate the expected frequency. In case of D, the first row and first column to calculate expected frequency, that means total of row, that means 1000, total of column, that means into 160 by grand total, that is 1500. So and once we estimate, we get the values of the, in case of operator A, the D first row and first column. So this is how we use the formula to calculate the expected frequencies. Let's move forward to calculate the frequencies. So this is a way. So if you look up the question, we need to calculate the expected D from operator A. So 1000, that was the formula, is total of row into total of column by grand total. That means total of row of operator A in case of div is 1000 into 160 by 1500. So 106.7, right? So the expected, in other words, we can also calculate, either you can use the formula of expected frequency of non-div, that is 1000 into 1340 by 1500. You will get the answer 893.3. Or in other words, you can also do expected non-div, that is 1000 of row total minus expected frequency of div from operator A, that is 1000 minus 106.7, which is equal to the 893.3. So this is also the way to calculate the expected frequency of div and expected frequency of non-div. Now we can come up to the expected frequency of div from operator B. So what is the operator B? Row total, that is 500, column total, that is 160 by 1500, that is 53.3. So if we calculate the expected frequency of non-div, that is 500 minus 53.3, that could be 446.7 could be the answer of expected frequency of non-div in you can say from operator B. So now we have estimated the expected frequency of all the value of all the cases, that is div and non-div in case of operator A and B. We just put the expected frequencies and observed frequency in an overall table. So as you can see, the observed frequency is already given and the expected frequencies are there. So div 106.7 and non-div 893.3, and same in case of operator B 53.3 and 446.7, which as you can minus 500 minus 53.3, you will get the expected frequency of the non-div 446.7. So how to calculate the chi-square value? We already have the observed frequency and expected frequency. So observed frequency 100 minus 10, and we just subtract the observed difference of observed and expected. So 100 minus 106.7, then 900 minus 893.3, 60 minus 53.3, and 400 minus 446.7. So once we subtract and add the expected frequency, we get the chi-square value, that is 1.41. We have used the formula which has already shown on the slide. So hypothesis says there is no significant association between the type of operator and divness, or null alternate hypothesis shows that there is a significant association between the type of operator and divness. So we need to calculate the degree of freedom and level of significance already given. So level of significance 0.5, degree of freedom, that is r minus 1, column minus 1, 2 minus 1 into 2 minus 1, the 1, and the degree of freedom for 1 at level of significance is 3.841. So what is the value of chi-square? That is 1.41. And what is the value of the chi-square tabulated value? 3.841. So what would be the result if the chi-square calculated value, that is 1.41, is less than the chi-square tabulated value? Then the null hypothesis is accepted. That means there is no significant difference between the deafness and, or you can say, but the deafness and type of operator. So there is no significant or statistical relation between the type of operator and deafness if, and it's shown in the result that the chi-square calculated value 1.41 is less than the chi-square tabulated value, that is 3.841. That means the null hypothesis is accepted. There is no statistical difference between the type of operator and deafness. That's all for today. Thank you so much for listening this lecture. I will come on to a more interesting, relevant, important topics in the upcoming session. Thank you and namaste to all.